All right, good morning. It's time for Module 12, cruising right along. We've got only 6 more modules in the class after this. So we are just flying through the material at this point. We will cover 2 modules this week, although they both have sort of the same subject matter. One just goes a little bit further in depth into object-oriented programming. The reason for that is that the week after this is, of course, spring break. So not that I expect you to spend your spring break working on this class, but it does give you a little bit of extra time, an extra weekend or whatever, to get stuff done and get caught up. So I'm going to sort of front load you with a little bit of material. And then when we come back from spring break, it's just going to be 14, 15, 16, and 17, and 18. But 2 of those modules don't have assignments associated with them. So we're actually getting close to being at the point where anything else that's assigned for this class is going to be considered the bonus material. Just like I said at the beginning of class, we have a total of 16 possible points for this class, and there are more assignments than that. So you can use the bonus material instead of a regular assignment, or you could just not do the bonus material and work just through the regular assignments. It's sort of up to you and how much you want to challenge yourself and what looks interesting and all that stuff. So anyhow, today we're going to cover something that is sort of like a more elite level programming concept. We're not going to get super deep into it with Python, but I want to give you some exposure because many of you will go on and take Comp 11 and 12 and get into more serious object-oriented programming. And by covering it here in this class, I give you the chance to like sort of come in with a level of expertise that I think will help you in that class. And then if you don't, I've given you enough to sort of start learning more on your own. So object-oriented programming is considered a more advanced programming topic, and it's sort of conceptually advanced rather than actually difficult to do. But sort of like functions and modules, it gave us sort of another layer of stuff that allows us to do more with less. Object-oriented programming is another one of those things. It's another layer that allows us to make more complex programs with less code. So the foundation of object-oriented programming is called a class. And the best way to think of a class is to think of it sort of like a blueprint. It's a model of something. So, let me just warn you up front that a lot of people feel like when we start talking about classes in an abstract way like this, and object-oriented programming in sort of an abstract way, they're like, what is this even about? Why are we doing this? It seems just kind of weird and unnecessary. But once you start using it, you can sort of see the power of that, and it really becomes way more powerful when you get into more complex programs. Even in the simple ones that we're going to be doing with object-oriented programming, you can kind of see it, but the more you use it, the more it's going to make sense to you. So I will say that. And if you get into using advanced modules, if you get into using sort of frameworks and things like that that are created to help you do things more easily in Python or any other language, you're going to use object-oriented programming. So you need to kind of know how it works so that you can interface with those things. So classes are like a blueprint. They define how something should look. And so if I'm doing like a blueprint of a house, let's say, we know that house is going to have, it's going to show where the roof is and what it looks like. It's going to show where the doors and windows are. It'll have parts to it. And then, but in addition to parts or properties, as they're called, values, classes also define methods or functions that live inside a class. So each class has things that it has as properties, or you can just think of them variables that belong to that class, but also methods or things that that class can do. And that's just a blueprint. So I use that blueprint to create things. And every time I create something based on that blueprint, it's called an instance or an object of that class. Okay? So for example, and this is one of those examples where you're going to go, well, okay, that just seems kind of like a waste of time. But let's say I create a class called car, CL car. And if I want to give it a property, I might say the number of wheels. Okay, so int wheels equals 4. So if I want to create an instance of that class, I would say, and just to be clear, when I say class CL car, it says I'm defining an object here. I'm creating that blueprint. So I use that and then a colon and then indented code for that code block. Everything that belongs to that class is indented, just like we've been doing with functions and everything else. So when I want to create an instance of CL car, I say my car equals CL car parentheses, empty parentheses for now. But just like we can pass parameters to a function, we can pass data to a class when we create it so that it belongs to that when I create that instance. Okay, so if I wanted to print the number of wheels in that car, I could say print my car. Notice the dot notation. So I print in the parentheses my car dot int wheels. So I'm accessing that property of that instance or that object. If I wanted to change the number of wheels to 6, I would say my car dot int wheels equals 6. So I'm making it clear that I'm changing the number of wheels in that particular car to 6. If I had my other car as another instance of that object, and I change my car dot int wheels to 6, my other car would still have 4 wheels because I just changed that one instance. It doesn't change what the class says, it just changes the instance. So when I want to create a method, if I'm using that CL car class again, under a class, I'm going to use the DEF the same way I define a function. So it's like creating a function inside a class. So if I say DEF start car, again, empty parentheses and a colon, indented again. So notice everything inside the method, inside the class is indented too, basically. So I'm creating a code block here underneath DEF start car. I would just have it like print vroom vroom, which is kind of a really basic, it's a very basic method. So if I want to create an instance of CL car, again, I would say my car equals CL car and parentheses. And then I would say my car dot start car, and it would execute that code. Now I could have this be a function that I could pass a parameter to just as easily. So that's something that's available to me as well. I could also, if I wanted to, have a variable that says, is the car running, true or false? And when I run start car, I could change the value of that variable to true, signifying that the car is running. So you can use a method inside a class to change variables inside that object. And the scope of those variables, just like when we have a variable inside a function, the scope of a variable inside a class only applies to that instance of that object. Okay? I know it's very, very ambiguous right now. That's okay. There's one specific method that we're going to talk about that you can use with anytime you create a class. And this method is automatically run. This method is automatically executed anytime you create an instance of the class. And a lot of times this is used to set a class attribute when an instance is created. For example, with the car model again, if I wanted to say DEF, and this is two underscores, DEF, two underscores, INIT, two more underscores, and then notice that there are three attributes or parameters here. The first one being self. Self is always there, because what we're saying there is when this initializes, when we create an instance of this, we're going to apply these things to that object itself. So notice, and then we have int car wheels and int car make, or string car make, str car make. And then below that, in that code block inside that method, I have self.int wheels. So I'm setting the variable of that instance called int wheels to the number of wheels. And so when I create this class, I have to pass it parameters, not three, just two, because self is already there. So you have to pass it int car wheels and str car make. And those automatically on creation get assigned to that instance of that variable. Don't worry, I'm going to show you this in another example that'll make even more sense. Okay, so when I create an instance of CL car called my car, now I have to pass it 4 for the number of wheels and Ford for the make of the car. And then I can immediately print out those values. Okay, so moving on, we've got this sort of the theory out of the way. Now let's start putting this together into an actual program. So assignment 12 for this module asks you to put together a object-oriented playlist. So I'm going to walk you through sort of the conceptual structure, then we'll look at some code, and then I'm going to turn you loose to play around with this. So the object that we're going to create, the class that we're going to create, is called CL Song. And each instance of that object will be one song on the playlist. Now, we're not actually going to create a music player. Don't get too excited. We're just going to create a playlist management app. So we've got these three are the properties of that class, or the variables that live inside that class. We have title, year, and rating. And then it has 4 methods in that class: get year, set year, get rating, and set rating. Get year and set year will either return the year that the song was made or set the year to a different value that you provide. Get rating will return the rating in terms of a number of stars or asterisk characters. And then set rating will change the rating of those. So each song contains 3 pieces of information: the title, the year, and the rating, as a string containing a number of asterisks. And it can do 4 things: get the year, set the year, get the rating, and set the rating. So if I had a playlist of these objects, of these instances of CL Song, I might have, let's say 5 songs on that playlist. And each song would say like Thriller 1980, 5 stars, Surfing USA 1963, 3 stars, and so on. So each of those songs, it's its own instance based on that blueprint that we talked about just a minute ago. So each one of those songs has the ability to set the year, return the year, and so on. But also it contains those 3 pieces of information about each song. So if I want to put all of those instances into a playlist, this is where the ability to put literally anything in Python into a list comes in handy, because all I would have to do is set it up as a simple array containing those instances. So I have AR playlist equals, and then in brackets, instead of pieces of data, I have those instances as part of the list. So now each element of the list is one of those songs in the array, which allows me to sort them, copy them, move them, remove them, do anything I can do with a list. Now I can do to one of those songs in that list. So if I want to add a new list item, a new song to that, I would use AR playlist dot append, and then in the parentheses, I'm going to create a new instance of that class. And I'm going to give it the information that it needs, which is the title, the year, and the rating as strings. I'm going to show you this in the code in just a minute. And then if I want to call the set rating to change the rating of one of the songs, let's say I wanted to change the rating of the first song, which is Thriller, from 5 stars to 3, I would say AR playlist 0, which is the first slot, dot set rating, which is the method of that class, and that method requires a string be given to it. So it now changes this, the rating of that song to 3 stars. And so that is how we would access the method of any member of that list. So let's switch over to code view here. And I will say before I jump into the code view that this assignment has a very lengthy set of instructions, and the reason for that is to give you some additional support and sort of direction and on how to put it together. Hopefully it's helpful. And then all the way at the bottom under resources is the sample code that I'll be looking at or going over with you right now in class, just to walk through how it's put together and how it works. Hopefully the sample code, the detailed instructions, and what we just talked about will sort of help you conceptualize how to put it together. Okay, so looking at the sample code, right, line 1 sets up an empty array called LIS playlist, list playlist. Just creates an empty one. And then I am creating the class. Again, talking about sort of the big idea structure of a program. Remember how I always say you want to import modules first, then you want to define your global variables, then you want to define your functions. I would say now we're going to define your classes before you define your global functions. So this is a class. So I'm creating the blueprint for a class called CL Song. The first method you should always create inside your class is the initialization method. Again, starting with DEF, and then 2 underscores, INIT, and then 2 more underscores. And then the first parameter that you always pass to the initialization method is self. Sometimes that's the only attribute or the only parameter that you pass to it. Many times you pass it other things. So in this case, it gets 4 parameters, self, and then 3 that are supplied by the user when we create the song, or when we create an instance of the song, the title, the year, and the rating as strings. And then what happens here in the next 3 lines is we're doing self.stringTitle equals str title. So we're creating a variable inside the object called str title, and we're setting it to the value that's passed to it as a parameter. The same with year and rating. Yes, sir.
Is the variable global here or?
No, it's passed in as a parameter, and then this is the reason it says self.strTitle is that it is creating a variable that belongs to that object. So it's the title of that song, It's the year that song was made and the rating that song has. So each time we create a different instance, it's there. You can access it from outside the object by saying the instance name dot str title. Okay. So, and I'll show you that in just a minute here. And then once it sets those variables, it says you added a song, just to sort of give the user some feedback. And then I have a setter and a getter. Those are common methods to be in a class. And all setters and getters do is either change one of the values of the variables or return the value of the variable. So if I say my song dot set year, and then I put a year in there. Now I'm leaving the year as a string. I could have put it as an integer. I'm just dealing with it as a string right now. I'm not going to sort or do anything math with it or anything. So it's probably fine to leave it as a string. If I wanted to do any kind of math, like find out the number of years between like Thriller and Still DRE, like I don't know why I would do that, but I could if I change them to ints. So set year and get year are the two other methods that I define. Now, as part of this assignment, you'll need to do the same thing for rating, but the model is here for you so you can kind of see how to set those or how to create those. I have a global function. So notice I'm out of the class now. On line 17 here, I'm creating a global function called main menu, which should be familiar to you by now. And that's it for right now as far as the global functions go. Now you will need to add other global functions. And notice I've done you the favor of putting them here. So when I look at your assignment, I'm going to actually be looking for these global functions that appear in the instructions. So I have very quickly added the first song. And this shows you how to add a song to the playlist. You're welcome, right? So I use LIS playlist, which is my main list that has all of the songs in it. So if you remember back at just a few minutes ago, I know it's a long time ago, we have this going on. We have this set up, and I'm putting the first song in there. So LIS playlist dot append, which is how we add an item to a list. And inside the parentheses is the class name, CL song. So I'm calling the blueprint. I'm saying make a copy of this blueprint, and I'm passing in the parameters, the three parameters that were in addition to self required in the initialization, right? When I create that initialization method, I'm asking for title, year, and rating. I don't have to supply self because it's already there. You can see that it's a different color here, so it's kind of set aside in the GUI. But I'm passing it string title, string year, and string rating. So I'm calling the class, and I'm giving it the title, the year, and the rating as strings. So I'm just doing that as right before I start my main loop of my program. So on 27 here, I've got a while true loop. I'm calling the main menu function, which just prints out the menu choices. And then I'm waiting for the user to provide me their input. And I've created the main menu for you, sort of the if-elif structure. So you're just going to need to fill in those other choices to make the program work. Now, I did the first one for you because I wanted to show you how easy it is using objects in a list to go through and print things. So if I want to list each song in the playlist, I just iterate through each song in that list variable, the list of objects or list of instances. And then for each one, I'm printing the .str title, which gives me the title of that instance. So when I run this, okay, you can see it says you added a song, Thriller. And if I want to view all there, then it just prints Thriller. I can come back in here. Let's just manually add one more song to it. So I'll just copy that structure and I'll put in something else. So that was, what year was that? 1999, I think. And obviously 5 stars. Okay, so now it says you added the song because when I append a new copy of that or a new object based on that blueprint CL song, it calls that initialization method automatically. It creates those variables inside that object, and then it prints out you added that song. So that was part of that code. And where did that go? Run. So now when I view all, it's iterating through the songs and putting that code there, or printing out the name of the song. I can really easily, if I wanted to, just print out more of this. I could go song dot, and look, when I say song dot, the first 3 choices are the attributes of that model. So I can print the year now. Let's run that again. Print. Okay, so added the songs, view all, and now I'm getting the song and the year. So it's now you can start to see like the power of working with objects, because each one of these objects in that list now has their own stuff. It has their own variables, but it's really organized. It's really easy for me to work with. So if I wanted to remove a song, how would I remove a song from the playlist? Any thoughts? Pop. Yeah, I could pop. And guess what? Because pop returns that value, I could pop that into another instance or another variable that would then contain that whole object with all of that data in it. It's really powerful what you can do with all of this stuff. So I could use pop, or I could just use delete or remove, whatever. And if I don't want to return that, but pop does the same thing. And if you don't capture what it returns into a variable, it just goes away anyway. So pop is the best way to do it, I think. So a lot of this is really just looking at this in a different way, and really, like, this is sort of the key in my mind to getting the conceptual structure of this, is just remembering that each item in that list is a copy of that blueprint with its own information, its own methods, its own variables inside it. And so you're basically working with adding these and removing them now. So that is assignment 12. And we will go a little bit deeper into object-oriented programming for module 13. But I think once you start going down this road and getting these pieces of it together, it'll make a lot of sense, hopefully anyway. And then we can build on that. And then after spring break, we're going to come back and get more theoretical, but there won't be assignments tied to some of that stuff, because I just want to sort of prepare your brains for future computer science studies at this point for those things.